Now, part this is to choose a method to determine the variance and standard deviation for the data set. All right, the data set, we have already transferred it to Excel. Here it is, the height and the frequency. So these are values that are already grouped, okay, in terms of intervals. Now, we have an idea as to what the variance and standard deviation does. It gives you an idea as to how varied the values are, yes? The differences amongst them, the spread of the values, how different they are amongst each other. And that's a very critical descriptive measure when you're doing data analysis, okay? So we're going to demonstrate how to do this when you have grouped data, data that is organized and frequency is present. So we go to the formula, and again, sigma is all over the place. Variance of grouped frequency and interval distribution. So here it is. Here are the two methods, method 1 and method 2. If you compare method 1 for grouped with method 1 for raw, the only difference is frequency. Frequency is not present. So bear in mind, this is the characteristic of raw data. Frequency is not present. But when the data is grouped, it is organized, frequency is present. So frequency is present in the formula, both the method 1 and 2 for grouped data. And as we know, the standard deviation is the square root of the variance. Okay, so therefore now let's carry forward this formula for variance for grouped data. The frequency is present. Transfer it to our worksheet. In your case, transfer it to the assignment. Format, so therefore now please show your working so you can get your format. Here's the formula, okay? Sigma is present. As we see, whenever you see sigma, ignore sigma, okay? Cover sigma with your form. Ignore sigma, and all what is to the right of sigma, complete it first before you sum. We know the sum of f is 70 because here is f alone that's there. F, the sum of f alone is 70, but we have to find the sum of that. Okay, so we have to find that first. We have an idea as to how to do that already. You go to your table. Oh, by the way, if you go into the assignment already gives you a head start for method number 1. Here's the table, here's the heading already. F times open bracket 15, okay? Because it appears that 15 is the first midpoint, 15 is our X, okay? And minus the mean, whatever you got for the mean, and then you complete and you do this, you know, gently for each one of them, okay? Doing it via Excel. Let's put our heading, F open bracket, X minus the mean, all squared. Double click, okay? First cell, the first one, F. The first F is 8. 8 is in C2. Equal C2 times, because you must put the times. If you just put the bracket, Excel doesn't recognize automatically. Look like they have not programmed Excel to recognize open bracket without the times is a time. So you must put the times, open bracket, okay? X was our first X. Our first X is in D2. D2 minus the mean. What we got the mean to be? I think it's 32.21. Where is it? 32.21. Here it is. 32.21. That's the mean. And just a reminder again, as you notice, you must find the mean before you can calculate variance and standard deviation, because the formula for variance has mean in it. So you must get the mean first. You see, you're trying to analyze the differences between the values. You have to divide the method to do that. So logically, the statistician say, okay, so let's calculate the mean, a central number, and let us subtract each value from the mean. Let's call that a deviation. So each value deviates from the mean because some are more and some are less than the mean. So let's calculate each deviation from the mean. Okay, and let us square that to cancel out the negative sign, because the values that are smaller than the mean, you're going to get a negative deviation. Okay, if you realize now, when we get 32.21 as our mean, you have those that are the 15s and the 17s and the 20s, the 30s are less than 32. So when you subtract these numbers from the mean, you're going to get a negative number. Okay, and then so that's the purpose for the squaring, to cancel out the negative number. And when you add up all those deviations squared, then you divide by the number of values. You find it like an average. You see, once you divide by the number of values, the type of average you find it. So the average, square up the deviations, and then you square it back now to give you the standard deviation from the mean. So it will give you a measurement of how different the values are amongst each other. So that is what is actually going on there. Okay, remember, we're in numerical analysis. That is the step, that process that's here, that the 1, 2, 3, 4th steps, 4th process in completing a research project. Very important. Numbers, descriptive measures to describe the data set. Okay, so that's what is happening with this formula. Okay, so going back to Excel now. So we have found the difference between D2 minus 32.21 all squared. Okay, because frequency meaning how many times is 8 of them between 5 and 15. So instead of doing it 8 times and adding, just multiply by 8. That's what is happening there. Okay, so let's go over that again. All right, you type equal, you type C2, that's where F is, because remember, F times open bracket, the X now is D2 minus, you see the minus the mean is 32.21 in my case, close bracket, squared, raised to the power of 2, enter. So that's the first value, the first F times X minus mean all squared. We want this in 2 decimal places. Right click, Shift F10, or right click, format cells, number, 2 decimal places. It automatically comes to default. Okay, go back to the green square, double click, go back to here to find the sum, the off, go to sum, enter, up, put this in bold, increase, size, 14, 14, okay. Centralize, right. So this is our numerator, okay. And for our working, we have fx, so we can just copy this for our working. Control C, go to the worksheet. All right, so we have already do this and add it, so we can reveal sigma now. Control V, here comes the blank spot, so we can go back for our text box. There it is. Control C. Control V. Okay. Control V. Sometimes it does not want you to do certain work in certain place. Therefore, S squared is equal to this value there, 10,469.29. Copy this, paste this inside there. The sum of F is already 70. All right. And then this was formula, right? This is not percentage, it's centimeters. This is not percentage, it's centimeters. This is not 25831. We have to do the division to get Control C, Control V, enter. 149.56. 149.56. Square root thereof will give us the standard deviation, a measurement as to how different the values are from each other. 12.23. 12.23. Okay, so this is like a measurement of how different the values are using the mean as a reference point, you see? So the reference point is the mean. You subtract each value from the mean. You square those numbers to cancel out the negative sign. You add them up, and then you divide by the total number of values to give you an average. Okay? Right. This number that comes here, that's the variance. Okay, and that is in centimeters. So therefore, the average spread or the average difference between the heights, according to method number 1, is 12.23 centimeters. Okay. Variance and standard deviation of grouped values using method number 1.